Okay, Longhorns, this is going to be the last section for this 6 weeks. We're going to be doing combinations and composition of functions. And for the first part, we're going to do the arithmetic combinations, which is basically the sum, difference, product, and quotient. This number 4 right here should say, this should say quotient. So I'm going to erase that and I'm going to type in quotient. All right, so the one thing you need to remember when you're adding or subtracting, dividing, and multiplying these functions together is that when you're subtracting, order matters, or if you're dividing, order matters. Because remember, when you subtract numbers, you don't get the same values. For example, if I subtract 5 minus 2, I get 3. But when I subtract 2 minus 5, I get a negative 3. So order does matter on the subtraction and the division of these function combinations. So be careful about that. The other thing you need to be careful of is that you need to make sure that the domains overlap between your two functions. In other words, the domain of one function needs to have values that are common in the domain of the other function, or you can't combine them. The domain consists of all real numbers that are common to the domain of both functions. That's the one thing that you need to make sure of before you try to combine functions. Most of the time this isn't going to matter because most of the time we're going to be working with polynomials. But if there ever is a chance that that could happen, that's one of the things that you want to check is to make sure that the domains overlap. Okay, I'm going to do example 1, and then we're going to jump over to example 10, and the rest of these problems we're going to do together in class. All right, so in problem 1, we are substituting negative 3 into our f of x, and they have given us f of x equals 3x minus 4. So what I'm going to do is I'm going to substitute in a negative 3 everywhere there's an x in our function. Okay, so notice that I have substituted in my negative 3, and notice that on this side, I have put my negative 3 inside parentheses. Anytime you substitute for x, and I don't even care if you're substituting x with a negative x, anytime you're substituting x with something else, you must use parentheses. And the reason is because if you make a mistake with this negative sign, your whole answer is going to be wrong. So make sure that you are using your parentheses. All right, so after I've simplified my equation, I get that 3 times a negative 3 is negative 9, and negative 9 minus 4 is a negative 13. So my answer here for this particular combination is that f of negative 3 equals negative 13. All right, so let's go to number 10 and take a look at that combination. Now in number 10, I'm going to be using g of x and h of x to do this combination in number 10. All right, so I have my two functions, and there's actually two ways that I can do this combination. I can plug 3 into h and plug 3 into g, and then add those two together. Or I can add the two functions together, combine like terms, and then plug in the 3 in for x. So I'm going to do both ways, and you pick the way that seems easiest to you. All right, so let's take a look at both of these methods. In the first one, I simply plugged in the 3 in for function h, and here I plugged it in, and the result I got was negative 1. And then I plugged the negative 3 into g, and the result I get here is a 23, and then I add my two results together and I get a 22. The second way to do this, if you prefer it this way, you can combine like terms of the two functions together first. So here I get 2x squared minus 3x plus 13, and then plug in the 3 into your function. and then simplify, and again, you should get the same number, 22. You only have to pick one of these ways. Whichever one is easy for you, that's the one you should do. And that's all there is for combinations. In the next video, we will look at function composition.